my name is Kyle Lamb, and I am the manager for the federal SEs here at DDN. And I'm going to give you guys a very brief overview of DDN Data Management. And there is a lot that goes on in data management for DDN, so this is going to be a pretty action-packed presentation with a lot of content, but without as much detail as you might like. So if there's anything that's of major interest to you out of the things that we cover, please make sure to see myself or somebody else here in the booth afterwards, and we can give you more information, okay? So starting out, a little bit of an agenda. I'm going to go over what we're doing for data management in the IME product itself. Basically, IME ends up being a data manager on its own, just to give us the performance tier of what we're looking for in our high performance workloads. Then I'm going to go over some of the DDN SFA, some of the components that we have that are integrated in at the hardware, software level to manage some of the data at that level. And then we will also go over GRIDScaler, EXAScaler, what we're doing for data management in both of those, as well as Atempo Digital Archive as well. So IME, starting off there. We all know that the application levels that are working against, or that are working on our storage are changing, and they are becoming much more dynamic. We have a lot more small writes, we have a lot more random I/O that ends up being seen at our file systems, and the application complexity that's going into that is also increasing. And so really we have a large-scale demand for something that can help us to address that, and also to coalesce those I/Os for us. So looking at it, really what IME provides is a data management system that allows us to cache all of that high performance small I/O, mixed random I/O, all into a persistent flash tier before it's actually hitting the file system itself. And so also along with that, it enables us to manage the data getting out to the file system much more efficiently. So looking at the scale out for that, we're utilizing NVMe as our storage tier in IME. And on top of that, it allows us to have unprecedented performance in IME itself. What that means is that we aren't actually accessing that NVMe flash as a parallel file system would. We're getting much closer to raw data rates that we have for those NVMe devices, because we don't have the overhead of having a file system tier on top of it. Now, it does accelerate, and its namespace is actually still resident in the parallel file system, but what we're doing is we're staging that data into this IME tier, allowing the applications to utilize that flash at near native speeds, and then staging that data back out to the file system, or conversely, staging data from the parallel file system up into IME if you have a read-intensive workload. On top of that, it does offer RDMA as the access protocol, so very efficient memory type access on those systems. So, looking at how does it scale. So we actually are deploying IME as a 4U or a 2U system, and we typically need 4 of them to be able to give data resilience. And so as you're looking at the scaling of that system, we can scale that out from 4 nodes, which would be our kind of entry building block, all the way out to, we have systems that are in production right now that are in the 50 to 60 IME node range, providing up to a terabyte or more per second of data throughput. And that all leads to your file system being able to more efficiently address the capacity of the system, rather than having to meet those performance demands. So IME itself is really just a software. We offer it as a software and hardware combined package, but it is the software that makes everything work, and we are able to deploy and sell as software only, although it does take some accreditation for us to do that and some work for us to do that. There is a lot of adaptive I/O. You're able to dial in the resistance, whether that be a set default that you want across the board, or whether you want certain applications to be able to change the resilience of the system, and so the default may be a 3+1 or a 8+1, and you may have some applications that are generating some very mission critical data that you want them to have an 8+2 or a 9+3 or something of that nature. And at the application level, we're able to actually change that and increase the resilience. Along with that, we do have lightning fast rebuilds on this system. It is a flash system, and so we're able to utilize the performance of that flash on rebuilds as well. So looking at that as well, one of the other key features is that a shared file on an IME system, you're actually able to scale that out across all of IMEs. So you do not have the logging mechanisms that are inherent in a parallel file system that cause performance strains. So it is a much more efficient utilization of that flash tier. So switching gears here to the SFA itself. The SFA is the building block for both our GRIDScaler and our EXAScaler parallel file systems. And I just wanted to jump into the data management at a very low level on those systems. So the SFA architecture is a SFA controller box with the associated expansion JPODs that are attached to it. And one of the really interesting things here is that even at this lower level, we are doing caching efficiently for small writes to that system. So you'll see that there's the React cache as well as a SFX storage cache. So whenever we're talking about data management, it kind of runs the whole spectrum of managing your data as a user would, but also managing the data and the performance attributes of these lower level hardware offerings. So with the same building block, we're able to build out a lot of flexible systems for you. So whether that be an NFS, a CNFS type of system, we have the same building block that we built XFS file systems out of, and of course our EXAScaler and our GRIDScaler storage systems as well. Another thing to discuss here or point out here is that we are adding in VMs as our controlling blocks on that. So if you're looking for the NSEs or the OSSs, we are building those as VMs in the appliance itself as well. So switching gears to GRIDScaler. So DDN is one of the largest sellers of, actually I guess it is the largest seller of spectrum scale. And so if you're looking at it, we have a nimble solution, we have on-site support for that, as well as referring out to IBM if it's a tier 3 type of issue. We do supply solutions for both HPC as well as for big data, and we are a company that actually has 20 years worth of experience of data at scale, so we're able to bring that to bear in a GRIDScale solution as well. And then also on top of that, we've done 2/3 of the top 10 are on GRIDScale, and we have over 1,000 successful solutions that are out there. So I told you that we utilize the SFA platform for both our GRIDScaler solutions as well as for our muster solutions. And so this is an image showing the SFA building blocks as well as the controllers. We do have room within that SFA box to actually add in NVMe as well as SAS hard drives to enable faster caching at the GPFS or the spectrum scale level. And on top of that, that solution is very efficient. It allows you to get some of the performance out of those SSDs. As I was talking about earlier, you're still going through a file system layer to get to that, so it will not be quite as efficient as our IME layer. So we offer protection for GRIDScaler in multiple locations, right? Not only do we have a building block that has RAID protection, and very soon we'll have a declustered RAID solution with it as well, but we also offer the solutions to move some of this data off of the GRIDScaler solution, so you can use things like cloud tiering, as well as we do integrate with TSM if you want to do a typical HSM deployment with GPFS, or I should say spectrum scale, going out to typically storage manager. Along with that, we also have replicated data sets within spectrum scale, and then we also do direct protect is a DDN feature that we're utilizing on that SFA underneath to actually do reads of the data as it's written, so that we can ensure that there's no corruption of data. So looking at the modern data center, everybody kind of wants to be able to support multiple different access loads to all of their data. And so using SpectrumScale, we're able to actually offer both the HPC workload as well as some of the more cloud-based offerings as well. Along with that, we also can utilize protocol nodes to offer up a GPFS solution as well as NFS, S3, Swift, and also some Samba access.
Somebody told me you just went around this way. I used to work
So looking at the unified file and object access, we do have that capability within SpectrumCell. So if you have a file that you have generated, you can actually access that as an object as well. And so that is available through SpectrumScale now. And then moving on to managing the data for a long-term solution or for an archive, GRIDScaler does offer the Advanced File Management Solution, so AFM for short, which allows you to take data from a publisher file system and move that data over to a backup or alternate site. There are multiple methods of being able to do that. So there's 5 different modes that you can utilize with AFM: a single writer, a read-only, a local update, independent writer, or a async disaster recovery. So switching gears now to EXAScaler, so our Lustre deployments. So taking a look at that, we've got multiple things that we're looking at, and that DDN specifically is contributing to the Lustre community. In orange there, you'll see that we have data lifecycle management as one of the key areas that we're making contributions. So looking at data lifecycle management, there's quite a few solutions that we've already, and contributions that we've already put together. We contributed a large portion to the Lustre project quotas, including a lot of work to the XFS, or the file systems underneath Lustre to make sure that we were able to support those quotas all the way through the system. We have DDN Lite, which is a Lustre integrated policy engine. I will give more details about that here shortly. We are working on developing and providing solutions that do an NFS and CIFS implementation, so that you can have your Lustre file system as well as having your NFS and CIFS clients be able to access that same data set and that same namespace. And then we also are doing some interesting work with Lustre on non-x86 platforms, both ARM as well as Power. And then we have quite a bit of work that we're doing in parallel data movers and bridges as well. So a little bit about Life, just to give an intro to it. Lustre typically has not had an integrated policy engine. There are other efforts that have gone underway, like Robinhood, to do a metadata scan of the file system. Life is different. It's not utilizing the changelog of Lustre itself. It is actually doing a direct file scan of the MDTs and pulling that information into a database so that it can look through that information and make decisions about looking for files that are over an age policy or that meet certain criteria. Parallel data movers, we do have some work that we've done in combination with some of the national labs on doing some of the parallel data movement, and so there's a lot of work around DCP, which is a collaboration with some of the national labs. So looking at, we have actually a few customers who are interested in us utilizing Lustre as an archive as well. It's an interesting thing to think about because Lustre has been at the forefront of performance for such a long time, and to think about having it and utilizing it as an archive is a very foreign thought process. Although the amount of resilience in the system has been gaining over time, and the stability of the product itself has made an amazing progress over the last 10 years. And so it's interesting to start thinking about utilizing that as an archive. And we have some customers who are very interested in us doing that. Going back to LIFE and a little bit more details on what LIFE actually provides for us. So right now it's doing that scan of the MDT, and it's doing that directly to the block level MDT itself. And so looking for key characteristics, whether that be some age of the files, whether that be extended attributes that you're searching for, things of that nature. It can go through that metadata target rather efficiently because it's aware of what the Lustre file system is writing out to the MDT as. And for future work on that, we're also trying to integrate that into a policy engine that we can utilize within HSM. And so there's some really interesting work that we're doing in this area. So some of the advantages of that system is that it's actually doing those direct metadata target scans rather than doing something that is based off of the Lustre changelog, which means that you can get out of sync or that you can lose some of the data, as well as the fact that you have to build a full system that is equivalent to your metadata system to be able to bring that data in and then process it. Along with that, it also has an interesting way of actually building rule sets for your scans. So you can actually do a quick scan through the entire metadata tree, looking for specific areas of interest, whether that be files that you're wanting to migrate off to an archive, or whether that be some interesting extended attributes. It is very easy to set up and configure. It is a single RPM and it's user space. And it does end up providing a web interface for your users to actually be able to interface with it. So an example of where we could use LIFE is in an integrated HSM. So doing a parallel scan or a scan of the MDTs in parallel if you're utilizing DNE, providing a target list, and then handing that off to our parallel data copy tools to move data from the Lustre file system off into an archive. So switching gears one more time, and for the final time here, I'm going to go over a little bit about Atempo Digital Archive. So we have a partnership with Atempo to provide a archive solution as well. It is not something that we have typically run, especially whenever we were talking to tape. But the partnership, whenever we were developing WAS, ended up working out quite well with us and Atempo. They're able to access our WAS devices with a RESTful API, which is very performant and provides us an easy way for us to provide a solution to our customers that gives them both access to a WAS solution so that they can have more of an active data set that's in their archive, as well as migrate some of the data off to tape if they decide to. So a little bit of definition between the two, backup and archive. Our use cases are typically more for an archive based off of our parallel file systems. So it does not currently do things like versioning and things of that nature, although Atempo does have a backup solution as well that does that. So the ADA software architecture, what it looks like, basically you have a GUI that the user is able to interface with that controls movement of data between your parallel file system in this case, as well as off to file storage, object storage like WAS, or off to a tape storage device as well. And there's extensible APIs that you can utilize to help manage that as well. Some of the GUI for it, just an example, display of the administration GUI as well as the user GUI. All of the activity of moving data into the archive with Atempo is user-driven. Although you can script things and do things of that nature, the emphasis is actually on making a nice user interface that users can access, move data from out of the archive into their parallel file system or vice versa. So there are some automatic tasks that are available for Atempo as well. So rule-based operations, things of that nature, whether that be copy, delete. You can integrate with the job scheduler if you wish. And there's extensive logging for the above. Some of the manual tasks would be more of that user interface to move data from one file system to an archive. So a proposed solution and one that we have actually implemented in production would be a tempo running with its data movers, moving data from a GRIDScaler solution off into a log solution. So that covers my whirlwind tour of data management within DDN. Are there questions? No questions? All right. Thank you all for attending and listening.